Okay. Okay, start.
Hello everyone, I'm Hantila Kosijalangun. Today my team and I will present our research on next generation firewalls. I will start with the background. Next. Introduction. Why traditional firewalls fall short? Traditional firewalls were built for a much simpler internet, port and protocol centric. They filter only by source or destination IP address and TCP or UDP port. It's like checking only the address on an envelope without reading what's inside. By to encrypt and SASS traffic today, over 80% of traffic is encrypted with HTTPS, TLS, or UQUIC, allowing port 443 can let malicious payloads pass unseen. Evasive threats. Attacker disguise malware as allow service slipping past simple stateful rules. Dissolving perimeter with cloud service, mobile networks, and hybrid networks. There's no single inside and outside to defend. Next. What is a next generation firewall? To meet this challenge, vendors create the next generation firewall, a single platform that combines classic firewall function with advanced threat prevention. This capability includes deep packet inspection layer 7 to examine actual content, not just header. Application awareness and control, so it knows Slack from YouTube, even on the same pod. Integrate threat prevention with built-in intrusion prevention, anti-malware, and URL filtering. User identity integration, so rules follow user or group, not just IP address. And last one, encrypt traffic visibility through TLS or QUIC decryption when permitted. Next. Why it is different. Next generation firewall provide context-rich security. For example, allow Slack messaging for marketing but block Slack file upload. They consolidate multiple tools, firewall, IPS, URL filter into one device and are cloud and hybrid ready. Running consistently in data center, bunch office, or the public cloud. Next, let's talk background and evolution. There are five generations of firewall technology. To see how we align at today's next generation firewall. Generation 1. Packet filtering. Starting in late 1980s to 1990s, firewall used simple access control lists. They filter traffic based on the basic file tuple, source and destination IP address, port, and protocols. This was layer 3 and 4 filtering only effective for its time, but very limited. Generation 2. Stateful inspection. In the 1990s to 2000s, firewall learned to track the state of TCP or IP sections. This allows smarter layer 4 decisions because the firewall knew whether a packet belonged to an existing connection or was starting a new one. Generation 3. Application aware or proxies. By the 2000s, we need more visibility. This generation adds limited layer 7 inspection and early form of application recognition, often by using separate proxy-based device. It was a step forward but still fragmented. Generation 4, next generation firewall. Around 2008 onward, the next generation firewall emerged. It introduced deep packet inspection, integrated application ID, intrusion prevention IPS, and user ID, all in a single platform with unified threat prevention. Last one, Generation 5, present hybrid mesh firewalling. Today, we see next generation firewall capabilities deployed across on-premise network, cloud environments, and branch office. They are centrally managed as a hybrid mesh firewall, giving unified policy and visibility no matter where the network lives. This evolution shows how firewalls have grown from single packet filter intelligent cloud-ready platform. And here's a quick side-by-side comparison of traditional firewall and next generation firewall. Next, my friend will talk for core capabilities.
So now let's dive into what really set next generation firewall apart from traditional firewall. I will cover 5 areas: inception depth, identity and application control, integrated threat prevention, encrypted traffic handling, and finally management and automation. Okay. Let's start with inspection and depth. Traditional, as my friend present, traditional firewall mostly operate at the lower layers around layer 3 and 4, and they can see inside the packet, which is they cannot see what's actually inside. If the traffic is a long port like HTTPS or 443, the firewall just let it through. So, but for the next generation of firewall, goes deeper all the way up to the layer 7, the application layer. They use something called deep packet inspection, which is the DPI, to read the application layer content. It is like instead of just glazing at the envelope, they open it and read it what is inside. So next generation firewall can tell the difference between the Slack and usual traffic, even though they are both use HTTPS. Why does this matter? Attackers often hide malware inside the alarm traffic. The traditional firewall would miss that. But with the DVI and network and next generation of firewall can spot the malicious payload and block it instantly. So the inspection is one part, but knowing who is behind the traffic is just crucial as this. So that is where identity and application control comes in. Traditional firewall usually tie its rules at the IP address. For example, for the 192.168.1.25 port address, it can access this server. The firewall doesn't know whether there is Alice from finance or bought the intern. And if the Alice switches the computer, her access doesn't follow her behind. So next generation firewall integrated with integrated with identity services like activity directory, so they map traffic to actual user and group, not just their IP address. So application control goes a step further. Instead of just saying port 443 is open, next generation firewall can say allow, select, and block the users. Like for example, oh, okay, for example, file next generation firewall also allow finance stamp banking access product to the Alice, but not to the Bob the intern, and it can even they are on the same network. So so it gives us a zero trust alignment. It gives a zero alignment to prevent that sensitive database says this is really crucial. So next generational firewall not only help in this area, and it can actually block threat. It can actually block threat also. This is when it used integrated threat prevention. Traditional firewall are pretty limited. They block or allow the traffic, nothing more. National firewall combine the IPS, the anti-malware URL filtering in one device. So it is like attacker send a malicious PDF through the normal web traffic. A traditional firewall just let it through, but a national firewall inspect the payload, detect the malware signature, and block it instantly. So it gets the real-time cloud threat intelligent, and if the firewall get the instant signature updated. So So the benefit is next generation firewall can stop the exploit and zero-day attack without separating the IDS and IPS. So it gives us the faster protection, lower cost, and fewer gaps between the different tools. But what if the threat is hiding inside the encryption, which makes us most of the day internet traffic? That is the next bit area. Today, that is the next big area. That today, 80% of the traffic is encrypted using the TLS and QIC technique. It is great for the privacy, but it is a nightmare for the security. Traditional firewall cannot see inside, so the malware or the data leak can stay hidden inside, and they will pass right through. Next generation firewall fix this with using the SSL or TLS inspection. They intercept the secure connection, temporarily decrypt it, scan the content, and then re-encrypt the traffic, be it before sending it on. Like for example, if an employee download a suspicious zip from the Dropbox, a next generation firewall can open it, inspect it, and block it if needed, while keeping the encryption intact and send it back to the user. So it also get header with TLS 1.3 and QIC, which encrypt more metadata and run over the UDP. But modern next generation firewall have adapted, and some can identify QIC traffic or even block it to force forward to the standard TLS that they can inspect. This isn't just about security. This is about compliance. In finance and healthcare organization are legally required to monitor the traffic. Without decryption, they would be blind. With next generation of firewall inspection, they can stay secure and compliant. Now, even all these advanced features like managing firewall by advanced feature that next generation of firewall offer, managing hundreds of firewall by hand will be really impossible. Really impossible. That is where management and automation comes in. Traditional firewall require manual configuration on each devices that is slow, error-prone, and hard to scale. Next generation of firewall solve this with a centralized policy orchestration. Admin logs into the, like for example, admin logs into the single console and define rules in the plain language like allow sales to use Salesforce and block the social media. Then the platform translates that into the right technical rules and pushes through to the every firewall worldwide, like data center, branches, and cloud. This reduce complexity, ensure consistency, and make it audit easier. For example, for another example is like for a multinational with hundreds of firewall rolling out, a new rule could take weeks, but with the national firewall, it will only take minutes to roll out. So it also use the automated threat feed update. They can connect that to the vendor's global intelligence network. When a new malicious URL or exploit is detected, the vendor generate a new signature and push it instantly to all next generation of firewall. That means organizations are sometimes protected before they even know the threat exists. The combined benefit is massive, faster responses, less manual work, and proactive defense posture that keeps up to the pace of the cyber attack. So when you put all of this capability together, national firewall is not just an upgrade, like it became a necessity for modern enterprise network. And my friend will continue about the enterprise and architectures.
Um, for the first thing, NGFW enforcement spans all critical choke points, data center ingress, egress, east-west ATS, campus edge, branch SD-WAN hubs, cloud egress, and inter-workload plex the IDO demarcation. A single policy and inspection model across these locations minimize configuration divergence and eliminates coverage gaps. Next. Initial phase contain immediate or active application sanction, tolerated, and shadow. Broad legacies, any server rules are replaced with application plus identity scope policies. Function level constraints, example limiting bulk uploads, reduce misuse risks. Prioritizing the highest volume legacy rules accelerates measurable reduction in shadow ID exposure and narrows the attack surface. Next. Inline IPS delivers virtual patching, blocking exploit signatures before host remediation. Threat intelligence and DNS controls disrupt command and control channels. Sandbox analysis produce rapid verdicts on unknown payloads, preventing activation. Segmentation constrains lateral use of SMB or administrated tools. Map to mid-tier attack, impair initial access, command and control, and lateral movement, producing marginally smaller blast radius. Next. Encrypted traffic now dominates enterprise flows. Attackers leverage that opacity. A selective decryption strategy targets high risk or unknown categories while examining regulated or sensitive destinations. Hardware acceleration and tuning preserve performance. Post-decryption, IPS, URL filtering, and sample verdicts operate with full visibility, surfacing concealed droppers and phishing content. Next. Zero trust principles are operationalized by binding policy to user group identity and precise application identification. Segmentation progress from macro zones, users, servers, OT to micro segmentation between application tiers. SD1 coverage applies identical policy construct as distributed edges while optimizing path selection. Outcome contain consistent least privilege enforcement and minimize lateral traversal potential. Next. Platform consolidation removes separate IPS and URL filtering appliance, lowering operational overhead, context-rich alerts, user application, threat fatigue, accelerate triage and containment. Key metrics contain rule count reduction, unused rule ratio, percentage of decrypted high-risk traffic, block high-risk application attempts, mean time to detect and mean time to respond improvements. IBS enablement follows a control path which include observe, tune, and false. Next. NGFWS operationalize zero trust principles by binding identity application semantics and content inspection into enforcement policy constructs. They reduce mean time to containment, shrink lateral movement paths, and consolidate multiple legacy appliances and yielding measurable economic efficiency and risk reduction. Next. These are our reference, and thank you for your attention.
I will stop share.